One of the special aspects in operation of ships is that they are undemanding about the type of fuel. The power plants of ships can operate with diesel fuel, light fuel, fuel oil, heavy fuel, as well as with various hydrocarbon blends, including a blend of diesel fuel and fuel oil. Another special aspect deals with refueling of ships directly en route, with the use of proper refueling ships that carry marine fuel in tanks. When it comes to fuel oil, the quality of this petroleum product deteriorates during transportation and storage. Oxidation and polymerization reactions occur in fuel oil and make hydrocarbons change into solids and precipitate. In the cold season, fuel oil is heated in railway tanks using hot steam. Furthermore, fuel oil is additionally water-cut. In worst-case scenarios, the amount of water in bunker fuel oil may reach 10 to 15%. Moreover, bunker fuel oil is actually a viscous substance. In order to ensure that it is pumped from a refueling tanker to a ship, steam heating is required as well. It entails additional water cutting. Water-cut fuel oil has poor burning qualities, the flame is lost all the time. The fuel is consumed in excess due to insufficient burning. The particulate matter that gets into marine fuel during storage and transportation affects complete combustion. Therefore, preliminary fuel preparation is required before combustion in ship power plants. In particular, prior to combustion, marine fuel should be cleared of particulate matter and water contained therein. The use of water-cut fuel is allowed as well, but this requires producing a stable and homogeneous water-fuel emulsion. If the first option is selected, in other words, when using pure marine fuel, preparation of this fuel is ensured by means of separators. This method is characterized by losing a useful volume of fuel which settles out in the form of sludge, as well as by difficulty in separation waste disposal. Fuel preparation in the form of a water-fuel emulsion is carried out with the use of homogenizers. However, these devices require powerful drives to operate, and the equipment capacity still remains low. GlobeCore has developed an alternative, innovative technology for preliminary preparation of heavy marine fuel. The main idea is to abandon conventional separators and homogenizers. In the fuel preparation process, they are replaced by a ferromagnetic particles vortex layer device, AVS. The use of vortex layer devices allows improving the efficiency of fuel atomization, the stability of fuel combustion and reducing the amount of harmful emissions by producing stable water-fuel emulsions. In terms of design, a vortex layer device constitutes an electromagnetic field inductor, an operating chamber, and ferromagnetic particles placed into the operating chamber. When voltage is applied to the inductor winding, a rotating electromagnetic field is induced in the operating chamber. Driven by this field, the ferromagnetic particles start moving along complex trajectories. At the same time, various physical and chemical processes occur in the operating chamber, including magnetostriction, acoustic vibrations, high local pressures, intense impacts of ferromagnetic particles on the particles of treated substance, and water electrolysis. These processes lead to intensive mixing and dispersion of fuel. Asphalt resin impurities, water, and particulate matter are ground and evenly distributed throughout the fuel volume. One of the options of a process flow diagram for water-cut fuel oil preparation by means of vortex layer devices is now available for viewing on the screen. The fuel oil heated to 40 to 45 degrees Celsius is transferred from settling tanks to a fuel heater by means of a self-contained fuel pump, and from there, to AVS 100 vortex layer device. After that, the fuel enters daily supply tanks of the main engine. A magnetic filter is required to clear the fuel of ground ferromagnetic particles. Optimal parameters for vortex layer device operation have been obtained during the operational tests. Capacity, 5 to 6 cubic meters per hour. Temperature of fuel oil preparation at AVS inlet 80 to 85 degrees Celsius. Weight of ferromagnetic particles in the device operating chamber, 250 grams. The AVS 100 device operated 4 hours a day. This period of time is sufficient to prepare 24 to 25 tons of heavy fuel for the main engine. It was found that fuel preparation in AVS 100 ensured producing a finely dispersed water-fuel emulsion resistant to breakdown, trouble-free combustion, and smooth fuel equipment operation. The results of microscopy of fuel oil samples showed that about 75% of particulate matter particles in asphalt resin impurities are ground to a size of 1 micron or less, and the remaining 25% are ground to a size of 3 to 5 microns. Testing the samples of water-cut fuel oil processed in AVS 100 showed that after 10 days of storage, there occurred no considerable coagulation of particulate matter and no enlargement of water globules. Furthermore, the combustion efficiency of water-fuel emulsion was studied depending on the water and fuel oil content. It was found that water-fuel mixtures prepared in AVS 100 with a water content of up to 25% were finely dispersed and resistant to breakdown. Their combustion in auxiliary boilers turned out trouble-free, no flame flickering was observed, ignition occurred smoothly, and burning was smokeless. Thus, the use of vortex layer devices in the process of heavy marine fuel production has the following advantages. A vortex layer device is pressure-tight and has no dynamic seals. The process is carried out inside the pipeline run through the central port of the inductor. The power consumption of AVS 100 vortex layer device is 4.5 kilowatts, and the optimal capacity is 4 to 5 cubic meters per hour. Therefore, the specific power consumption will not exceed 1.1 kilowatt-hours per cubic meter, which is 10 times less than that of conventional marine fuel production units. Due to fine dispersion and intensive mixing, one AVS can replace several devices at once in fuel preparation processes, fine filters, separators, homogenizers. There remains no waste fuel in the event of applying an AVS vortex layer device, while it occurs during the use of separators. The processes of producing finely dispersed emulsions and suspensions are accelerated 100 times in AVS due to intensifying factors inside the operating chamber. Fuel treatment in a magnetic field prevents resin and paraffin depositions. Reduction of harmful emissions into the air due to production and subsequent combustion of finely dispersed and stable water fuel emulsions. What kind of equipment do you use for heavy marine fuel production? Share your experience of using this equipment in the comments section. For more information on GlobeCore heavy marine fuel production technology, please follow the link in the first comment or visit our website, www.globecore.com.